Your voice is not audible, sir. You are unmute only, but still it is not audible.
Hello, good evening. Can you hear me now?
Yes, sir.
Okay, good.
Yes, sir.
Good. Yeah, good. With the headset. Yeah. Okay. So, as people are discussing in chat, this is a session where, in general, I will not speak much. I'll give a very brief overview or some remarks I may want to say, and then I'm hoping that you will use this to um, get clarifications and questions. Um, But today I will quickly go again. These sessions are recorded and put in the portal. Somebody shared. But today I will just quickly go over what I did last time and then add a few more remarks and leave open for questions and comments. Um, we're still not decided on our regular meeting time because different people have different requests, and I had several constraints. So we are meeting Sunday this week, and next week we may resort back to Monday. We are still waiting for response from people on the form Kirtana sent about your preferences, and based on that, we will take a call on our regular meeting time. Okay. Okay. Good. So for those who missed, I'll quickly go over what I showed last time. This is a course primarily targeting teachers, but yes, students are welcome. I keep saying teachers and not so much students is that while it'll be beneficial for everyone to get an overall view of the motivation. I mean, I keep insisting that motivation for each topic is what I'm going to focus on because I have done faculty development programs and be part of interviews for many students who have taken algorithms course. Now, if I you may be very familiar with AVL trees and BFS and dynamic programming, but if I ask you, why do we need AVL trees? I find that people get stuck. Even teachers get stuck. So that's why this course, I will not focus so much on the details of implementation of some of these things, partly because, that's not the whole motivation. Also, that's something people I believe who have done the course, who have taught the course, do it as a matter of routine. And also this is in real world, when you go and you're not going to implement some of these things. It's useful for you in the course to implement once, but many often there are libraries available, there are LLMs available that you're going to take advantage of, but you should know at what situation, what data structure should I use, what technique I should use, and that's why my focus is more on the motivation part of it. Okay, so um, feel free to stop me, unmute yourself, and ask questions. While I'm presenting it, I may not be able to check the chat window. So if you have a question, you can do a brief interrupt, unmute, and ask me. And otherwise, I'm going to keep going with what I have. So this is a course. What is this course about? We're going to do a quick refresher, is what I'm saying, and at a high level, and that's also the second point on basic topics in data structures and algorithm. We're trying to compress 2 semester course in about 2 to 3 months, and so it will not have all details, but it will have the motivation part, which is normally missing, in my opinion, in some of the courses. The focus will be on what and why rather than how. And I already said, for example, we won't discuss the insurance in the AVL trees, but we'll discuss why avial trees are important. We'll follow a problem solving and bottom up approach. So that means typically every lecture in the video will start with a problem, and we will apply some known solutions for it. See, this is the way I think you should learn this, that rather than talking about this big, powerful, good data structure or technique, you will see if that's not there, how do I go about coming up with solution for this? And then after trying various attempts, you will appreciate the new solution. But um, because comparing solutions requires performance analysis, so our entire journey will focus on complexity analysis of the solutions. That's how you can understand why one solution is better than the other, appreciate the new solution. Yeah, so hopefully all of you have seen the videos. The lecture one just sets the terminologies and starts with the search problem. As I said, every lecture is going to be a problem, and we give some simple solutions and get on to binary search and do an analysis of binary search. And even at that point, I'll say, suppose I also want to organize my data and I want to support the insert operation also in logarithmic time. We realize that the simple array or linked list may not work. And then we will have a quick review of stacks and queues. And then I talk about the problem of supporting insert and delete max. And here again, I will first start with insert and find max, and we will have a very simple, nice solution. And then we say, if I also want to support delete max, what happens? And we'll see that the tools we have are not sufficient enough to support that operation in logarithmic time. Now, these lectures, in some sense, in my opinion, sets the whole course in perspective, because bulk of data structures course in any course is all in any curriculum, standard curriculum, has these two big data structures: a collection of this balanced binary search trees, and then a bunch of um, priority queue. And you understand from this lecture 2 and 4 why you need this heavy duty machinery. They are not really heavy, but at least the simple array linked list solutions don't work. And when I say don't work, they don't give you logarithmic solutions. So you will not be able to appreciate the new structures and the whole course without doing complexity analysis. And I'm emphasizing this because I also know that in most courses, they do not do the complexity analysis. And without that, you will not be able to appreciate why this new tool is more interesting. Okay, so that's what first 4 lectures are. And how do you use the course and follow the lectures? Particularly for teachers, start with forgetting whatever you already knew. This helps you to get into the minds of the students doing the course, right? Because the students typically coming with a basic programming course, they probably have done a C, Java, or Python course. They know a little bit about array list, and that's how they're coming in. Maybe they know a little bit about sorting before they come, but certainly not so much about complexity analysis. And I will not encourage you to delve deeper into the definitions and this big O and so on. So if people need some sessions on big O, we'll do it. But I don't believe that for a data structures course, it's heavily needed at all. Complexity analysis is needed and important, but not so much delving into the intricacies of big O. Because then it focuses people on, say, the holy grail in the whole data structures course is about trying to do everything in log n time. And why log n is important, and I would have dealt with in one of the videos. And think of it as that's my goal in the whole data structures course. When we get to algorithms part of it, we will try and do different things. And then the second thing is also about the template, right? That problem, and you have a set of objects you want to support, so to maintain and support certain operations. That's what the goal is about. Use these as starting slides, and I want to emphasize again, these are not the entire material. You need to do whatever you normally do, your slides, or refer to the books into the details of some of the data structures. I believe so. I was part of the AICTE curriculum committee which designed the courses in data structures and algorithms, and we believe that these are enough and fundamental, basic to understand these data structures and algorithms. So, if your curriculum, for particularly for teachers, deviate too much from these, my suggestion is to get it cleaned up and organize it, because that's what the ACT suggests, and that, in my opinion, is good enough. And more importantly, as again somebody pointed out, these weekly sessions are recorded and put in the portal, but it's in your own interest to participate so that you can ask questions and get them clarified. Okay. Let me pass here and ask, there are any questions or comments so far? Okay. Yeah. Anybody has a comment?
Yeah, thank you, sir. Thanks for these are very helpful. One of things I couldn't very much get into that the recurrence relations while
Okay.
discussing the binary sets.
Okay.
So the equation starts with a t of when n is zero. So I guess this is a number of data items.
Yeah.
So how this is then this says so t of n is equal to 1. So this next line I'm not understanding and onwards. So can you please help
So
with?
when n equal to 0, I say t of n is 1.
No, n is equal to 0. If n is equal to 0, we exist. So t of n equal to 1. So how this
Sorry,
goes?
no, it's the other way. When n is 1, n is 0, we don't even bother. N is the number of elements. When n is 1, when you have only one element, the number of comparisons you perform is 1. So t of n is 1. When n is 1, t of n is 1. I don't remember, I don't know where 0 comes into picture. If I have said 0, that would have been a mistake. I'll check that out. But so basically t of n is the number of comparisons performed in the algorithm. Okay, it is a function. It's a function of the input size. T of n is a function of the n. N is the number of elements. Okay, that is given to you. N is the number of elements in the input, and let's call it T of n or C of n as the number of comparisons made by our algorithm. When n is 1, then the algorithm will make only one comparison. So C of n is 1 when n is 1. And then when n is bigger than 1, then we are doing some comparison, and then we are splitting the input. So it is T of n is 1 plus T of n by 2. Okay. So 0 does not even come into picture at all. There's no 0. I don't know. If I had said 0, it would have been a mistake. Yeah.
Yeah, I think that's slide and that's 0, but that's now clear. Thanks so much.
Okay. Okay. Okay.
Thanks.
We'll come back to this if there is any question.
Yeah.
So every week or most of the weeks, we have a problem sheet, and typically very short, about 2 or 3 problems in incremental difficulty level. And they are there just to make sure that you understand the material being taught. If you're a teacher, it gives you new problems for your students. And again, they're fairly easy. So again, the reason if you are a very capable student and you want some challenges, then certainly these problems are not going to give you challenges. For such people, if you can send me an email, I can give you more problems and have more advanced material for you too. Because there are 100 people taking the course, and mostly teachers. I am taking I don't want to scare away people. These problems are just to test your understanding. and so they are not very hard. And then I'm giving you 2 weeks. In the first offering of the course, every week we had the deadline, but now I pushed it to 2 weeks because I just want people to do the problems. That's the goal. Another thing I find that people are not used to writing solutions, because most of your questions and writing is all something like MCQ questions or very short questions. So this course will also give you some practice to write solutions. Okay. Maybe after the first assignment is due, I'll publish the solutions. You will get an idea of how to write also. Now on the problems, they are not, as I said, first of all, they are fairly easy to try on your own. Secondly, in these days of internet and chat GPT and LLMs, you will be able to find solutions very easily, but you're not going to learn if you just do any such thing. Okay, so do the problems on your own. The question is not clear, you can ask in this session or send me an email. Fix up a time. I'll be happy to talk to you. Send me, or the TA Devi Amini can have a chat with you and help you clarify the questions. Okay, but final certification, there'll be a set of regular problem sheets and a take-home final exam. So I'll give final exam. I'll give you. It'll be very similar to the problem sheets, but more problem sheets and very little time given to you. Maybe about 4 or 5 hours instead of 2 weeks. The final grade depends on your performance. The last time I picked best 4 of the problem sheet solutions and your final exam. And yes, here are some very important do's and don'ts on the problem sheet, which I did not put it up last week. So please pay attention. I want to okay, I'll come back to you can ask me suggestions, you can discuss with your friends. Plus, my big suggestion is don't go to internet for solutions because they are there. But even if you do, the important thing is to submit your own solutions, because there is widespread copying among students, among teachers I have faced, and this is something it's a clear no-no for my course. Okay. You can discuss, understand solutions, because you're not going to learn otherwise. The whole point is not get a grade in this course. The whole point is to make sure you, at the end of the set of lectures and problem sheets, you become a better person to teach, or you are equipped to understand many of these topics much better. That's the goal. So by copying, you are not going to gain that. So submit your solutions, acknowledge discussion. So you can put in your solution, if you consulted somebody, discuss with somebody and say that this part I discussed with so-and-so. But more importantly, you should be able to explain a solution in a Viva. So if we find that there is some copying that has happened, I'm going to call that person, fix a time, have a person explain me the solution, and you will get credit for that problem or the assignment only if you are able to explain it. So important things to do them. Copying is strictly forbidden. In particular, we have had cases where people just copy line by line the entire, take a Xerox copy, scan, and submit the solution. We can easily make out, if we see it doing this more than once, then we are not going to look at your assignments, and you will not get a certificate for that course. Okay. Final comment, very important, write short solutions, because somehow writing pages and pages, all my questions require about 1 paragraph short solution. Okay. If something is not clear, I'll be happy to have a chat with you to get more clarification. So don't write 2 pages. Typically, any solution for any problem running for more than 1 page, we are not going to look at it. Okay. So I just want to make that clear also. Okay. So now again, let me pass and ask for any comments. So somebody says, I've taken reference for internet for second assignment problem. Is it okay? Well, as long as you are able to write the solution yourself, please write it, and maybe acknowledge where you picked it up from, that's fine. Yeah, I'll be happy. If necessary, I may ask you to explain me the solution. Yes, Rathikanta. Yeah.
Yes, sir. Good evening, sir. Sir, actually, I'm a student, so I am not that much strong in those type of analysis problem. So just I'm learning and taking some kind of reference or like that. I mentioned in the assignment also. Is it okay, sir?
Yeah. First thing, don't say I am a student, I am not strong. Everybody is in the same boat. People who have
Okay,
taken the
sir.
course, people who have been around for long, who have taught the course, in my opinion, all of you are in the same boat. Very good, capable people who have shown interest to do the course. That means you will do very well. All you need to do is to put in that effort to understand it. So, okay, to go to internet to understand the concepts. I would discourage you to go to internet to find solution for a problem. If something is not clear, binary search recurrence is not clear, yeah, go ahead. There are hundreds of videos. It will only confuse you. Simpler thing maybe to write to me or to the TA, have a discussion, get that clarified. But feel free to go to the internet to get the concepts clarified, because in these days, I can't stop you from picking up things from elsewhere. But don't take your problem and go and look for solution in internet, because then you're going to be spoiled by that approach every time you come across a problem. Take time to understand, do them on your own. Okay. Where do you look when you find any doubt? As I said, you can look at internet for understanding some concept, but if you have a doubt on the question, please write to me, I would suggest. I respond to emails. I mean, immediately, within a day, you will get response to emails. You can copy me and the TA so that one of us will respond. And if things are not clear over emails, we can have a meeting to discuss it also. So I'm happy to fix up some time to discuss that. So um, again, feel free to go to internet to understand the concepts, but it may actually, with internet is inundated with so many videos on algorithms that it may actually add confusion. But if I'll leave it to you. But don't take the problem, go and find solution and then write on your, copy it. Even if you do something inadvertently, make sure you understand it, because there is so much noise. Not everything you see in internet is right. So you should be able to absorb it, understand it, and write on your own. Okay. Here are some books and online resources. Again, many of you know this. Introduction to Algorithms by the CLRS, as they are called, Corman, Lysers, and Rivest. It's very comprehensive. It everything. Still misses some topics with complete description of algorithms, problems, examples, pseudocodes. It's heavy on proofs. Proofs are very important in my opinion, but the proofs in CLRS may not be very compact. There may be other books that give you better proofs. Um, Kleinberg and Torres is another book I have referred to. It's very good for graph algorithms, NP completeness with several practical examples. There is a book by Jeffrey Erickson. There are a lot of other books. I don't want to specifically recommend this or that. If any, I think they may all add more confusions to you, but you can gently refer to them. There are lots of lecture notes, videos available. And somebody sent me this website where you can actually see codes and tools. I have no experience of it, but I thought I will share them anyway for you to try. So we will put all the slides, or I will write separate sheets and put it in the portal, so you don't have to bother copying about it. So here are some email addresses, very important. Can note them. So if you have any complaints of accessing the videos, anything with registration, once eventually when you get marks, you will all be sent the marks. Any questions on them? Write to Kirtana. She's the coordinator for this. Kirtana T@nptel.iitmacin. Any questions on material problems, even marking, you can write to me or to the TA Devi Amini. Okay, so now I'm going to stop here and ask for questions. Unfortunately, I'm out. I don't have my tab here to write something, but I can only do mentally. But next time I'll get that fixed. Okay. Gopinath Sundarajan asks, can you define abstract data type? Yeah. So the way I defined my data structure problem can be considered as an abstract data type, right? So abstract data type simply says, here is the set of objects and here are the set of operations I want to support. That's an abstract data type. So you don't call stack as an abstract data type. You don't call heap as an abstract data type, but priority queue is an abstract data type. Priority queue says, I want to call, support, organize or maintain a collection of numbers and support these two operations. A new element is coming, add it, and I want to pick the highest priority. Every element comes with the priority. So a number is basically a priority. And delete the highest priority element. These are the set of objects along with the operations together form this abstract data type. And your abstract data type can have multiple. So this is called, you can think of it as a last in, first out, or a priority queue. You can implement it using a binary heap, binomial heap, Fibonacci heap, array, sorted linked list, whatever. These are all implementations for a data type. Similarly, stack would be, I want to support last in, first out. So there are insertions and delete the last inserted element. This set of operations along with the data form this abstract data type. The implementations of array, linked list, heap, whatever you want to use, those are implementations of the data type. But I know, don't get bogged down by these definitions and so on. But the important thing is the implementation is hidden from the user. From the user point of view, user says, here is my object, user doesn't even know computer science. User doesn't know your data structures. User says, here is my objects, here are the operations I want to support. That's an abstract data type. Now you take that and you say, okay, this is actually a priority queue data structure is what I should use. There are so many ways of implementing priority queue. I'll use that. Okay, any other questions, comments? Yeah, so where will, in fact, people who want to ask, if you can unmute and ask, maybe others can listen to it rather than even chatting. We don't need to necessarily use the chat, but whatever you feel comfortable. Where is data structure algorithm implemented? I don't think I need to emphasize that. Everything you see around is a data structure. Google is an example of a data structure engine, because it just organizes the websites to support some queries. Shortest paths or connectivity, graph, maps, they're all implementations of algorithms. Now, Where is it used? Yeah, there is a widespread application. But if you say, oh, they're all done, what is new? There is always something new there. And more importantly, it's like calculus. I mean, you can simply ask, where do I use calculus? But it's just this whole course is a problem solving course. You are learning some tools and techniques and some interesting ways of solving problems, which you will take it and in your real world, you may not necessarily use a particular sorting algorithm, but when you come across a problem, you will relate to this and use something, some tool you've learned. Could you speak about data structures in the context of AI and ML? No. I mean, in the big data world, everything is algorithms. You have to organize them. You have to deal with, find some function of the data. You need. I mean, in fact, the LLMs are able to do so efficiently, so fast. They can answer your queries simply because of the algorithms behind it. Okay, so again, will I pick up something from here and will it be useful for the job I am going to do? That's very hard to say for anything you learn in computer science or math or anywhere. But it's all about learning the tools and techniques, and the concept of problem solving per se will be useful. Power iteration graph data structure. I don't even know what that is. So I'm not going to answer that. How will you differentiate between data structure and ADT? I mean, don't get bogged down by these definitions. Think of this big picture of what are we trying to do in the whole data structures course. Array, list, trees, or some structure where your data is organized. And once you put some values on the data and add more constraints, together they form data structures. You can have heaps, sorted array, balanced binary search trees, B trees. These are all some data structures trying to solve some abstract data type problem. Okay, so what we are going to cover is classic basic material in a typical third year or second year data structures and algorithms course. Okay, that's what this is going to be. Now, why is this course even there in the curriculum is a bigger question. Okay, yeah. But the point is that if you want to learn the material in the course, which is structured, which is there already in the curriculum, and understand the motivation for each of these course and the problems will be useful. Okay, any other questions, comments? Yeah, so for the next 1 or 2 weeks, we will please pay attention to the emails until we set on the regular routine. And if you have not told your preference, please add in the email Kitana sent from user 53. I think that's the mail from which it comes. Yeah. Okay, if there are, all right. Do we have any WhatsApp Telegram channel group? Good question. This was pointed out last time and I left that to my TA Devi and Kitana to figure out. So hopefully, if there is a plan, we will let you know in a week or so. Yeah. Okay. Can you provide some PDFs and lecture notes other than the videos as study material? I don't have any, and there is so much resources available. Um, um, I don't think I want to add more to it. And to answer Deshraj and Ratikanta, do this course well. Yes, Kaushik has a question.
Good evening, sir. Am I audible?
Yes, you are. Go ahead.
Sir, I have a question. I'm a student and I'm very new to computer science per se. So I have often come across this term called heuristics whenever we talk about algorithms, and I found it quite confusing. So could you please say, like in very simple terms, what do we mean when we say heuristics in the context of algorithms?
Okay, good question. Yeah. When we say algorithm, typically it is to solve a problem, and it should stop, give correct answer all the time, and then we sit and analyze that algorithm. Heuristic is simply an idea. So later on in the course, or we will see some very hard problems which are very difficult to come up with efficient algorithms. For such problems, people use what are called these heuristics, right? Heuristics will lead you to some algorithm, but the problem is not clear that that algorithm will produce the correct output all the time. Unless we are sure about it, we will not call it an algorithm. Heuristics is simply an idea. So for an algorithm, heuristics can be a starting point. Oh, here is an idea. Why don't I take the larger, let's say I want to find the shortest path between a pair of points. I'll say one heuristic would be I go to the closest point to me, and then from there I go to the closest point, and so on and so forth. It's sort of a greedy heuristic. We call it heuristic at this point because we don't know that finally it will result in an algorithm which will produce correct output for the question all the time. So, yeah, so that's the difference. Is that clear?
Yes, sir. Thank you.
Heuristic is some sort of an idea. It may or may not result in the correct algorithm. It may result in some method, some algorithm, but you will call it an algorithm for a problem only if this produces the correct output all the time. Now, how do we check it? This is what this course is about. Theoretically, you will be able to check that this algorithm, binary search, for example, will definitely find your input, whether it's present or not, all the time. But a heuristic would be, why don't we try and do it here, search there, kind of a thing. That's just sort of a starting idea. To convert it into an algorithm, all the details need to be worked out, and you need to ensure that it actually gives the correct input, correct output for all the input. Then we will worry about analyzing the complexity of the algorithm.
All right. So if I understand correctly, then so heuristic is like basically a process to start. When you're trying to solve a problem using a more systematic, using computers, say, then it could be just a process by which we are trying to solve the problem. But this process can be completely wrong in trying to find a solution, right?
Well, wrong is a too strong a word. So, for
As in
example, let's say we are trying to solve the optimization problem. Okay, suppose you are trying to minimize. I want to find the shortest path. That's an optimization problem. Not any path. I want to find the shortest path. I want to maximize my returns on an investment. These are all optimization problem because you're trying to optimize something. Now, if I want to optimize it, if I'm sure this approach would actually is the best, it gives me the best solution all the time, then it will be an algorithm. Otherwise, it's an heuristic. Heuristic is something day-to-day term we will use, right? Why don't we try that? A good heuristic would be to do this, do that. Maybe in the market is low, I'm going to buy more things is a good heuristic. But it may or may not result in necessarily the optimum solution. So heuristic is a sort of a loose word. But in computationally hard problems, people use only heuristic and work on some benchmark problems. Okay, here is a problem where people have found very difficult to come up with solution. I'm going to try this heuristic, and this gives me something better than all the solutions I have seen so far for the problem. So it's a heuristic, but it is an algorithm. It may not, it may be wrong in the sense it may not necessarily give you the best solution. So wrong is a too strong word, but yes, you got it almost right. Yeah.
Yes, sir. Thank you. I think it's clearer now. Thank you so much.
Yeah. Is jugaad the nearest word for heuristic? I don't know. These are loose words, but these are not formal technical words. Yeah. Okay. So thank you very much. If there are no more questions, we'll meet next week, and stay tuned for precise information, our next meeting time and the deadlines and things like that. Yes, do heuristic give optimized solution always? No, that's exactly what I said. It may not. That's why it's called a heuristic. Okay. Good night. I'll see you next week then. Bye for now.
Good night, sir. Thank you.